Welcome. Just want to do the next video in our conversion series from going from AGM batteries to lithium iron phosphate. As you can see, the system is running at this time. We've got the majority of the wiring cleaned up. We still need to come back and finish putting the panels and covers on everything, but that'll happen as one of the final steps once we have a little bit more run-in time on the system to make sure we don't have to make any further adjustments. But you can see that is our main panel there. Contains our shunt trip breaker as well as our bus bars, which are feeds from our two charge controllers there, which are Outback FlexMax 80s, and the 80 amp breakers, which go from the output of the FlexMax charge controllers down to the bus bars, which is where our batteries tie into and our inverter ties into. And we've covered this before, but there's our inverter. It's an Outback rated 8,000 watt inverter, which is comprised of two 4,000 watt inverters in the same cabinet. They will share the load internally between the two 4,000 watt units, as well as it is grid tie capable, but we are not grid tie. It's strictly an off-grid system. We do use utility power as a blend, so in the event that we're not generating enough solar, we will take grid power and blend it into what we're producing for solar. And we also, depending on the season and the amount of sun and nightly loads, we'll also, if needed, turn this into, it has several modes, and one of them being UPS mode. So we'll put it in UPS mode, and then what will happen is, if in case we ever lose grid power in the evening or at any time it's in UPS mode, it functions like a computer UPS would, meaning it will then start drawing from batteries to power loads. And you can see the Outback hub kind of stayed in the original position it was in before the rewiring. Seemed to fit good there. And you can see our first functional lipo 4 bank, which the cell name is CALB, and these were used cells that came from battery hookup, came out of an electric Volkswagen conversion, had a few cycles on them. These are 180 amp hour cells. We did load test a few of these, and we managed to get 175 out of 180. So these cells are pretty much functioning as if they were new. We've had them in this solar grid array now for the last week, and they function fine. What we're going to do today, however, is add another 200 amp hour capacity into this bank via another 2 sets of strings. Now you can see our long mons as part of our Batrium BMS running on these batteries. And obviously you can see the main Batrium monitoring unit there, along with its associated external power supply and breaker. Again, that external power supply is a DC to DC converter, basically. We use 48 volt banks here, so it takes the 48 volts, steps it down to 2 strings of 24. One output we use to power the watchman, and the other one we use to power the shunt trip breaker, as that ABB, and most ABBs are 24 volts for that shunt trip. And this was a separate purchase. I'll link his video, but a gentleman whose channel's name is Lithium Solar actually showed this, and this is what he uses with his setup and his shunt trip breaker, and I like it. It's a nice problem, or a nice solve to the problem, to you be able to use a 24 volt shunt trip breaker with a 48 volt system. Now there's other ways you can do it, such as using a resistor in line with it. There's other individuals, as I've said in previous videos, that just run the 48 volts to the shunt trip because you're only hitting it for a few milliseconds to trip the breaker. It is a 24 volt coil in there. I'd rather not run a resistor or supply it with a full 48 volts. Therefore, I did the same thing Lithium Solar did and went and got one of these units, which does mount to a DIN rail that you can kind of see back here, along with the main breaker, which is tied into this external power supply here. And it works out quite well. Actually, I do like that solution. And you can see one of the things I wanted to show was the Longmon wiring. Now this is where the Longmon chain starts and ends. And per the instructions, when you're wiring up your Longmons, or any of your cell monitors for that matter, the direction in which you start your daisy chain for your data dictates which one of the cells in your bank becomes cell 1, 2, 3, 4. They suggest you start with the most negative. I did not follow that suggestion because that would have made my first cell here on this end. I did not want my number 1 cell here. I wanted my number 1 cell to be at the opposite end. Now with that, it meant that we had to extend the data cabling, because a typical Longmon cable, and excuse the shaky cam here, I'm going to grab one of these monitor cables. That is your typical Longmon cable, as well as I believe it's the same cable they use for the cell mons and leaf mons and then so on and so forth. So the Longmon I know and the Cellmon I know use this same cable. I'm not sure if they all do, but regardless, for our installation here, this unit here, it started with the 4-pin connector. Each one of these has a 4-pin end and a 2-pin end. And the procedure to get to cell 1, at least for me, started with this adapter. And you have a 4-pin cable here that, remember, this is the same cable. So if this is a 4-pin here, you have a 2-pin on this end. So we took one of these cables here, cut it in half, and then used some Cat5 cabling to lengthen it, and then wrapped the cable into this nylon braided material that you see here, just to protect it and give it some additional rigidity. And we extended that cable to be the very first one that plugs into that cell there. So on this end, it goes from a 4-pin connector, comes down, comes all the way over to the first Longmon that you see here. And we have it tie wrapped for the cable here just to provide some support to this, because you'll notice that when you deal with this cabling, you're dealing with some rather fine strand wiring here, so it is a little bit delicate. So one of the tips I would say, if you're going to be dealing with a Batrium system and ordering your Longmons, order some extra of these cables, connecting cables. Because you're going to want some extra ones in the event that you damage one or have to add more to your system. They're relatively cheap to get a hold of, and if you're going to be spending the money on a Batrium system, go ahead and order about 10 or so extra of these, just so that you have them. So remember, on that end we started with a 4-pin, comes over here to the 2-pin end, and then it loops. Data chain loops from that point forward. We then take the next Longmon, you can see here, is 4-pin to the 2-pin on the next one. And then 4-pin to 2-pin, 4-pin to 2-pin, all the way down the chain until we get to number 16 here. And you'll notice we end with a 4. So we started with a 4 off their block, went to a 2-pin on the first Longmon. The very ending Longmon is a 4-pin. Remember, these cables have a 4-pin end and a 2-pin end. 4-pin, it has also been extended, comes back over here, and then plugs into that 2-pin port there. So again, you're just completing a loop. These long mons talk in a data chain that is just one big loop. If you can think of it in networking terms, if you're a PC individual, the old coaxial cable networks that they used to do between PCs, in which the coaxial cable literally looped from machine to machine to machine to machine, and then made its way back around again. So, and that setup has worked well, and we did the same thing on this cable. As you can see here, we just tie wrapped the cable to this existing negative battery cable, just to give this some support so it isn't trying to hang by its weight. Again, it is some fairly thin cable. Not that that's bad, it's fine, but we just wanted to give this support so it wasn't hanging by its own weight and, you know, potentially causing some type of long-term issue. But that's worked fine. And what we're going to do is we're going to add, again, like I said, 2 more additional strings of 16 batteries. We'll be adding 200 more amp hours to this system, but we're going to be using a slightly different prismatic cell. Again, these are 180 amp hour CALB cells. We're going to move over to what you see sitting next to them, which is in the process of being set up. Those are Fortune 100 amp hour cells. These came from electric car parts company. There'll be a link in the description. I originally found these batteries and saw them in use via another fellow YouTuber that does DIY solar as well, and his link to his channel will be in the description. First name is Will. I can't pronounce his last name. I'm bad with it, so I'm not going to try. But a link to his channel will be in the description. And these Fortune 100 cells, I have to say, are quite well built. These are meant for EV application, meaning you can see here they are aluminum encased. They come with fairly beefy terminals that can be bolted down to. You can see the vent for each battery there at the top. And it comes with these top and bottom holders. Now you'll notice they're not secured to the battery, but you'll see a opening through here in which you can use standard threaded rod, which you see down there at the bottom, available from any hardware store, to go through these rods and help to keep the pack in line and together. Now keep in mind that these aren't physically attached to the battery. Now once you put the bus bars in place, that'll help lock the top cover in, but the bottom cover of the battery is the same way. It won't be locked in. So don't use your threaded rod as a support system and then try picking up the battery bank by the threaded rod. It's not going to end well. But the threaded rod will help keep the batteries together, like you see here, sandwiched up against one another, and depending on pretty much whatever configuration you want to have them in. We're going to do 16 batteries, as you see here, with the first bank just back to back to back, and then wire accordingly. Now, again, these batteries here, they are meant for EV, specifically for EV applications. A lot of individuals like myself are going to use them in a solar application. These are capable of a continuous 200 amp discharge. Not that we're ever going to see that type of a discharge on this system. You know, they are capable of it. So as with any lithium system, I've said it before and I'll continue to say this, treat lithium with the respect that it deserves. If you're going to be using a lithium system, again, I'm using Batrium here as a battery management system. You need to have some type of battery management system on a lithium battery bank. That is my opinion, but it is an opinion that I'm going to stick with. So just to show you real quick, so this video doesn't get too terribly long, on the second shelf here, you'll see where we've got one of these Fortune banks in the process of being built. You'll see a long mon wiring just kind of hanging there. And let me give you some light. And there we go. Hopefully that doesn't blind you out. We're in the process of getting the long mons installed. And what we've chosen to do for the long mon installs, and I've seen a lot of other individuals do this, there's two of those little cable management 3M spacers that have the double-sided sticky tape. And if I can find one here, one moment. Pardon the shaking, kid. Just digging through a box here off camera. Show you one of these. There we go. That's what we're looking for. And there it is right there. It's just a little cable management piece with some double-sided sticky tape on the other side. And then what I'm choosing to do is on these long mons, you'll see a little indent on the top and bottom of it. And we're just zip tying the top and bottom to one of these cable management pieces and then sticking them, as you can see there, to the side of the battery. And we're in the process of getting the negative and positive feed that will be the cell voltage monitor for each long mon wired into the top, as we're also assembling the battery bank, or I should say battery pack in this case. And then when we're ready, we'll come by and break that communications loop that you saw on the first battery and add these long mons into that communication chain. And there'll be a little bit of a sequence for that. And as you can see here, another one of these cables that we've made where we've taken their cable and extended it. What will happen is the communications line from the very first bank that you saw at the top will come down, hook into this first long mon, daisy chain down, come out of this long mon at the bottom, go to the first long mon of the second bank, and then daisy chain down, and then finally go back up and plug into that little adapter that you saw on the wall. And we'll do another video when we get to that spot, just so that you can see it. What we're using for bus bars, when you order these batteries and you tell electric car parts company when you do your order what your configuration is going to be in my case it's 16S. They were gracious enough to give me 60 of these bus plates here. Each plate can handle 150 amps. So what I'm going to do is, since I have the extra plates, I'm going to double up those. So it'll be capable of 300 amp between each bus connection. Again, not that this pack will ever see a 300 amp draw, but I've got the extra bus plates. They're specifically made for this application. They're here. We're assembling the pack. We might as well use them. Now, each battery, and I wanted to show you this as well, each one of these cells also comes with a cover that snaps onto the top of these to help protect it. So not only does it come with, again, these which you can put threaded rod through to help hold the cells to each other so they don't fall over, and these nice big heavy terminals that you can see here that you can bolt down into. But once you're done with all your wiring, it also comes with these nice little top covers to help protect the top of the cell so you don't inadvertently drop something on top of this and end up having a very bad day. Also, to show you here, one last piece on these fortune cells, and not that I'm trying to be a fortune cell salesman here, but this is the bolt that they give you. Hopefully you can see that there. You'll notice that they all have the nylon lock washer in them. So once you get these in place and tighten down,
that nylon will grab onto those threads and basically help lock this into position. Because again, you got to understand, you got to remember, these batteries were meant for an EV application, meaning if you're going to have them in some type of electric vehicle, they're going to be subject to vibration, and that nylon insert will help keep these bolts from vibrating loose. Again, it's a very nice, just heavy built battery, and they do have multiple quantity pricing on their website, meaning the more batteries that you buy, the cheaper that you can get each unit for. So we have a bank of 16 below that you've already seen. We're getting ready to work on this second bank of 16. So we'll have 32 of these Fortune 100 cells that will eventually be added into the existing 16 CALB cells that you see here. So these are LiPo 4, those are LiPo 4. If you're going to be dealing with lithium and you're going to have multiple strings that you see here, the battery chemistry has to be the same. Because we're going to be, or at least in my case, they definitely have to be the same, because I have one battery management system, that's the Batrium, and the Batrium has been configured to be LiPo 4, as well as my charge controllers have been configured with LiPo 4 charging profile. So again, so in my case, you definitely wouldn't want to have a LiPo 4 bank mixed with a standard lithium ion bank or some other lithium chemistry. You want to keep all the chemistry exactly the same, especially if you're going to be tying strings of lithium cells together. And keep your chemistries the same. Again, and if you're not comfortable with doing electrical wiring that you see here, then don't do it. By all means, hire a professional, seek help. Do not attempt to do any of this on your own if you're not comfortable doing so. As you see in the disclaimer below, these are not how-to videos. These are documentational videos only, just to show you the decisions I've made going down this particular conversion path. And with that being said, I will let you go, and we will come back as we get closer to adding these banks or newer banks into the overall bank and getting them tied into the Batrium system. Other than that, that is all we got for this video, and thank you for watching.